The 2E10 Buggy project is based on the design and implementation of a model light rail transport system like the Lewis. As a project, it tested our knowledge of both computer and electronic engineering. We were provided with buggies, which featured infrared sensors on the bottom to detect where the track was, another infrared sensor on the top to detect pulses from gantries located around the track, ultrasonic eyes to detect obstacles in front of the buggy, an Arduino Nano microprocessor to combine all this information together, and an XB wireless communication device to send it all to a controller program running on a laptop, written in C#. The track in this case is a black line in two parts, the main circuit where the buggy goes around, and a parking lane. On the track are 3 gantries, and on each of these is an infrared LED which emits a pulse unique to each one. The top sensor on the buggy allows us to read these pulses and identify which gantry the buggy has reached. We implement the line following logic for the buggies in hardware. This means that we have to design and solder logic circuits in a breadboard to determine when to turn the left and right motors on. We also have to write Arduino and C# code for the buggies and control tower respectively. The Arduino software collects information from the buggy and sends it to the controller, which then decides, based on our program's logic, what the buggy should do. The gold standard for this project consists of having 2 buggies on the track at once, never being in the same section as each other except when they're coming into park. So as the first buggy moves off and reaches the first gantry, it continues because there's nothing in the section ahead of it. The second buggy, however, has to wait at the first gantry until the first buggy has cleared the second. So as they continue on, the first buggy reaches the third gantry and continues on, and the second buggy reaches gantry 2 and comes into park. The first buggy is now free to go around and park itself. Now the gold standard bit of this challenge is to have the buggies swap around and continue and do another round of exactly the same thing. As a team, we had regular meetings to discuss any problems we may have been having and to split the tasks and responsibilities required for the coming week. We tried to swap roles as frequently as possible so that every member got a chance at each aspect of the project's design. This meant that everyone knew what everyone else was doing and could fill in for them if needs be. Because of this, our team was very resilient and would not have been greatly affected had one of us been ill or otherwise unavailable. In terms of our design, we kept as much of the decision-making logic in the C# controller as possible. This was to allow the Arduino to focus purely on the immediate information being generated by the buggy, rather than worrying about where the other buggy was or whether it was time to park. It also means that all of the command logic can be manually overridden from the control station in case of malfunction. Our controller code is written to be easily extensible so the system could support more buggies or gantries as needed. Of course, there were a few failures along the way. Almost every aspect of the buggy failed in some way at some point, and throughout the project we had to put in a lot of extra hours as a team to come up with solutions and get back on track. This cooperative attitude and willingness to work long and hard to achieve our goals is what we feel defines us as a group. We've been D3, thanks for watching.